Okay, so in this video, I'm gonna walk you through a bunch of examples of solving equations from section 6.4, from section 7.1, 7.2, and 7.3. When you get into chapter 7, they're asking to solve equations to use identities, and it's in most cases. And I'm not going to ask you to go through and work out all those other identities. Um, you'll see the double angle formula certainly in calculus, but and Calc 2, if you go beyond that, you'll need some of the others. But at least you'll have seen them once, and you'll have to get through this course. So here we go. So we've got this equation here. We want to know when does the sine equal to 1/2. And they're asking us to find all solutions, and in all solutions, what does that mean? What you've been doing, I mean, you probably at this point you're thinking, oh, all I really need to do is I need to do the arc sine of 1/2. Well, we know arc sine has output. Here, let me make this a little bigger. We know arc sine has output in quadrant between negative pi over 2 and positive pi over 2. So that's where the output's going to be. And I see, what do I see? I see, let's see, we know sine is y. So I see that answer right there. So pi over 6 is one solution. We do most of this work in radian measure. Okay, to warn you up front. Most of this work, you'll want to give your answers in radians. Sometimes they'll ask you, certainly my open math, they might ask you a degree, but usually we do this in radian. So that's an answer, right? Pi over 6. But as we did back when we did the inverse operations in that last week in section 6.3, we also see there's another angle that has a y value, y coordinate positive 1/2. So that's two solutions. If we make another whole trip around the circle, we're back to pi over 6, but isn't that more than pi over 6? So what's happening? How do we find all solutions? And we certainly don't want to list a bunch of answers. That's a pain. So what we can do is let's look at what's happened with this graphically too. Here, let me add in this picture. No, cancel, not that. Here, let me stop this video. So what we're seeing here's a graph of sine x. I had a graph. I had a graph the line y equals 0.5. So really, what we're doing is like systems of equations. When does this curve intersect this curve or that line? And we see there's the pi over 6 that we saw in the unit circle. And here's the 5 pi over 6 and then of course on the negative side, on the negative side, see this is one cycle of sine x. It's one trip around the circle, right? From 0 to 2 pi. And then it repeats and looks like it crosses again there, back here. So there's a bunch of solutions, and how did we come up with an expression to express all those solutions? So what you're seeing now is I got Desmos to label all these for us, and they labeled these nicely in radian measure. So here's the pi over 6 solution, and this is where the graph here. Let me do some drawing here. So that's where the graph went like this, right? It went up like that, down, and then like this. And then it repeats. Here, let me go to a different color. Then it repeats, and it crosses again. So how do I come up with an expression? Well, let's see. Remember how we talked about going all the way around? So here's one tripper. Here's the first time around. And then here's the point that's in the exact same place, right? That's on the way. That's up in quadrant 1, right? So there's the pi over 6, and we're coming back around. And that's getting 13 pi over 6, it says. Well, where's that coming from? Well, we know that it's pi over 6 plus 2 pi. And another name for pi at 2 pi is 12 pi over 6, because we're going to get common denominators, right? So 1 pi over 6 plus 12 pi over 6 is 13 pi over 6. I mean, it's off the graph, but if we could do that again, I would take 13 pi over 6 and add another 12 pi over 6, and that would be 25 pi over 6 is what Desmos would tell us if I had it graph that. So what you can do is you can say, well, I know I got to go another whole revolution around. So what we could say the first answer is going to be pi over 6 plus 2 pi times however many times around we're going to go. So that's one set of solutions. That takes care of all those solutions in quadrant 1. And now we've got all those solutions that are going to happen over here in quadrant 2 at 5 pi over 6. Well, that'll be the same kind of thing. 5 pi over 6 plus 2 pi times however many times go around. If you notice, you see that 17 pi over 6? That's this point right here, which corresponds to that point. And if you think 5 pi over 6 plus 12 pi over 6 is 17 pi over 6. So this is how you express it with all solutions. If they tell you just between 0 and 360 or between 0 and 2 pi, then you're just going to list the pi over 6 and the 5 pi over 6. Okay, so this is the part you need to do for all solutions. Okay, now we're looking for the tangent of theta. Well, let's see. I see it's positive. It's looking for all solutions. I know tangent will be 1. Well, I know it'll be positive. Remember, all seniors take calculus. All students turn crazy. Whatever you want to use. That's only going to happen when this side and this side are exactly the same. And well, that's going to happen with an isosceles triangle. So maybe you already realize that that's pi over 4. And again, we could say go all the way around, add 2 pi over 4, or add 2 pi k. But with tangent and cotangent, it's a little different because we also see that tangent is positive down here in quadrant 4, or quadrant 3, I mean. And that'll be the same kind of deal where it's pi over 4. So we know the reference angle is pi over 4. So we could say, what is that going to be? 5 pi over 4? I could say 5 pi over 4 plus 2 pi k to get all the way back there. But however, isn't this just 180 degrees, your pi units? So we can take care of all of our solutions by just saying times pi or plus pi k. And that'll take care of there's the 5 pi over 4. It'll go back to the 9 pi over 4. Then so on and so forth. So we don't have to worry about the two sets of solutions with tangent. Now we get to do a little algebra. Well, let's see here. Move that over here. So I got to isolate the cosine. If I subtract 3 root 3 from both sides of this equation, remember that's 1 root 3. 1 root 3 minus 3 root 3 is negative 2 square roots of 3. That equals 4 times the cosine of theta. Then I'm going to divide by 4. Here, I'll write it this way. 2 over 4 reduces to negative 1/2. So this is negative root 3 over 2. That looks like a unit circle question. So I want to ask myself, where's the cosine negative? I mean, because sometimes what's going to happen is it's not going to be a unit circle question. Where's the cosine negative? Well, I know that everything's positive here. I know only the sine and secant here. So here's the solution. And let's see, where is x? Remember, cosine is x. So I'm seeing right there, that's where it's equal to negative. So 5 pi over 6 is a solution. And it's also negative down here, because remember, only tangent and cotangent is a positive here. So cosine is negative, because that's the x-coordinate, right? If the x-coordinate's negative over here, the cosine's negative. So we're looking for what? We're looking for x is negative 3 root 3, or right there. Whoops. Let me undo what I just did here. How do I do that? Let me go to a yellow. Let me go to a highlighter. There we go. There's the other solution, which is 7 pi over 6. So I'm thinking, let's see, they don't tell us solve for all solutions. So I think we're going to assume, and usually you'll see on 0 to 2 pi. Notice they have it open at 2 pi, so in case it's a quadrantal angle that ends at 0 and 2 pi, we don't have to worry about 0 and 2 pi. I'm seeing what? I'm seeing 5 pi over 6, and I'm seeing 7 pi over 6. And we'll just stop there because they didn't tell us to do anything else. So those are the two solutions. And we could graph this. We could graph this side and the other side and see where they cross on Desmos. That'd be a good check. We want you to be able to do this algebraically too. Okay. Now we did a problem that was very similar to this, to the very first example. Remember, it was sine theta. Now it's sine 3 theta. So here's some things we can do to help ourselves out. And we're going to pretend that this is all solutions, okay? In my open math, they'll ask you to find like the first 4, and you'll see one of those here. Let's pretend we're going to find all solutions. And that'll help us out. So the first thing we're going to do is we're going to pretend that 3 theta is just theta. So, and I'm going to do this little substitution. I'm going to say u. So really what I'm doing, and u is just, it's arbitrary. It could be anything. Where does sine u equal 1/2? Well, we already knew from our work before that this was what? It was pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k. Now that was when it was just theta, but we have 3 times theta. So what we're going to do is we can divide both sides by 3, which means we're going to multiply. I think it's easier to think of this as we're going to multiply by 1/3, and we're going to multiply both of these by 1/3. So that'll become 5 pi over 18 plus 2 pi over 3k, and this will become what? 1 pi over 18 plus 2 pi over 3k. Now, I want you to think about this for a minute. Why is that 2 pi over 3 here? And you were doing graphs of sines and cosines, that was an important number, or important feature. I hope you thought, oh, that's the period for this graph, this sine 3 theta. And we could graph this in Desmos and would see they would repeat every 2/3 of pi. Okay, so that's why it's shrunk up the period, it's going to hit it faster. Okay, so that's here. Let me make sure I highlight this in this mess. This looks kind of, so this is an answer, and this is an answer. Boy, this didn't get pulled into the software very nicely. Basically, it's an equation. Well, you've done some work on this like this already, and back in section 6.1 when you're talking about the sine and cosine. So really, what we have is here. I have a midline of 50. This isn't required to solve this equation, by the way. But I think it'll help you understand what's going on. So I'm going to take the time to do it. 24 hours, not 25 hours. We have a midline of 50 degrees. The amplitude is 10, so it's going to be as low as 40, as high as 60. And it sounds like San Francisco. And we know it's been reflected around the midline, and it's got a period of pi over, the period is 24, because I knew that because 2 pi divided by pi over 12. I don't know if you can read that through the mess. 2 pi over 1 times 12 over pi. The pi's cancel out, 24. We kind of knew that though. So then what's this graph going to look like? Well, let's see. It starts at midnight at 50. At 6 in the morning, it drops down to 40. At noon, it's back up to 50. At, let's see, what is that? That's 6 in the afternoon. It's up to 60. Then back down to the average at midnight, more or less. So there's that graph. And they're asking us, how many hours after midnight will it be 55 degrees? Well, here's that line, y equals 55. So that's the point we're looking for, okay? And so it's somewhere between 12 and 18, or between noon and 6 p.m. That's where it starts climbing. So how do we do this algebraically? Well, we know we're going to solve this equation. 55 equals negative 10 times the sine of pi over 12, was it h? I guess we could use t, plus 50. So I want to isolate the sine graph, or sine part. I want to isolate, let's see, let me make sure. I want to isolate this piece right here. So I'm going to subtract 50, and I'll divide by negative 10. So 5 divided by negative 10 is negative 1/2 equals the sine of pi over 12h. So then we can do that same kind of u substitution. We're going to think, and you don't even need to write this down if you can handle it. I'll write sine of u equals negative 1/2. Well, we know there's a look at the unit circle, it's going to be, u is going to equal, let's see, what is it? Negative 1/2. Well, I know the arc sine, well, maybe I better do this out. I know the arc sine of negative 1/2 is going to give me a negative pi over 6, or negative 30 degrees. We'll keep it in radian form answer. But time in the past we aren't really interested in. We also know there's another answer over here where that's pi over 6. So let's come up with our answers. Well, I know that this red angle is going to be that one. So that's going to be pi plus pi over 6. So that'll be 7 pi over 6. And then if I want to get back there, I got to add 2 pi times k. And the other answer will be, though I don't think we need this because it says when it first answers it, but I'll write it in just because I will. So what's that? That's going to be 11 pi over 6 plus 2 pi k. Now, since the question did ask us when it first hits it, we'll probably just go with this red one. Now, what I'm ignoring is that 12 pi over h. So I'm going to come back up here. And I'm going to erase this other answer because we don't need that for this word problem. What is it? Pi over 12h. Pi over 12h. So just like I did back when we had that sine 3 theta, I'm going to multiply by the reciprocal of 12 by pi over 12, which is 12 over pi. And that'll isolate the h. And I'm going to do 12 over pi times 7 pi over 6 plus 2 pi. Maybe we don't even need this part, but I'll include it anyways because it'll help us for later on. Let's see. So the 12, let's see what happens. 6 goes into 12 twice. Pi's cancel out, so that's going to be 14 plus the pi's cancel out plus 24k, right? So that would mean at hour 14, which is what? 2 p.m. So at 2 p.m. it would first reach 55 degrees. Then we'll add 24 hours to get to the next day, right? So that's how you solve this, basically. And then we're missing, I'm ignoring this part where this is coming down. I know I erased all that. Oh, I've got it up here, don't I? Can I move that down without us seeing it? I see I missed. I'm not worried about this solution here, but that would come from, if we were, we'd find another answer, and we'd have to worry about that. We'd have to worry about that 11 pi over 12, this one here, or 11 pi over 6 it would be. And we'll do that. We would do that same kind of thing. Okay, so hopefully that helps you solve that equation. I'm not totally sure how clear I was with that. So now we're into calculator kind of solving, okay? So one thing I do notice about this is that they have me working in radians because it's 0 to 2 pi. So when I ask myself, so I'm going to do a little getting ahead here. I know that sine is negative below the x-axis. I also know that arc sine will give me an answer here. If I were to do the arc sine of this, make sure your calculator's in radian mode, of course. when I did this earlier, I came up with, of course, calculator gave me negative 0.4115. I just worried about it as the reference angle because I can't have an answer of a negative angle because they want me to be between 0 and 2 pi. So I've got this answer, and I've got this other one that's over here because that's the other place, that's the other angle where sine is negative. And that also has a reference angle of 0.4115. So to get the answer, we'll have to take pi. We'll have to add 0.4115. And that will give me that answer. And then to get this this other value, I'm going to take 2 pi and subtract 0.4115. And that will give me that angle. That will give me this angle here. Okay, and I'm not going to bother finishing calculate those because that's just calculator work. But that's the kind of thinking you got to do to catch these. So let's see here. Let me try to get ready for the next one. So then cosine is 0.7. So I know cosine is positive here. And I know it's positive here. Because remember, all seniors turn crazy. All positive cosine's positive. So when I do the arc cosine to the negative 1, right? Arc cosine of 0.7, my calculator earlier told me, here it is, 0.7954, and I know that reference angle is also 0.7954. Well, since this is in quadrant 1, that's one of the answers. To get this other angle, I'll have to do pi, or 2 pi, minus 0.7951. And that will tell me whatever this angle is here. Okay. Let's see, let's clear this out. So cosine is negative 0.8. I know cosine is negative here in quadrant 2, and I also know it's negative down here in quadrant 3 because the x is negative, right? That's the negative 0.8, and that's 1. I really don't care what the y is. So because my arc cosine will give me output in quadrant 1 and quadrant 2, my calculator is going to give me that answer, whatever that answer is. I honestly didn't crunch it, but I'll just do the arc cosine of negative 0.8, and I'll get whatever that answer is. Then to get this other angle here, let me go green here. To get that angle, isn't that pi plus that answer? So that'll be pi plus whatever this answer is. Okay, and that will take care of that. And then tangent of 3. I know that tangent gives me output. Arctangent gives me output in quadrant 1 and arctangent give me output in quadrant 1 and 4. Now, where's the tangent positive? Well, it's positive here in quadrant 1. It's also positive down here in quadrant 3. So if I can do the arctan of 3, that will give me this angle. And from what we learned before, that's just an additional pi. So we'll just take and add pi to that answer. Okay, so whatever your calculator tells you that is, you'll add pi to get the other two answers. And that's the two answers that are between 0 and 2 pi. So hopefully that helps. So here's a problem that's got, it says wants 4 solutions, all 4 solutions. So it's easier to think about this as find all solutions, then we'll just list the first 4. So, I don't know, what do you think? How are we going to do this? I hope you said, oh, I'm just going to pretend this is sine u equals 1/5. So then I've got to ask I know this isn't a unit circle problem. This is going to be a miserable question. So where's the sign positive? It's positive here. and it's positive here. So that will be the other answer, okay? And then we got to find for the first four solutions. So we'll do the arc cosine or arc sine of that. We're going to do the arc sine of I was going to say 0.2 of 1/5. And here I got to get a calculator. I don't have this. I want to do this one out, and I haven't done it yet. Let's see here. So let's see. A second sine of 0.2, I'm getting 0.2014 if I round. So that's that reference angle right there. And then the other answer is going to be, since this is also 0.2014, I'm going to do pi minus that to get my other answer. 1/4, Dan. So pi minus that answer, I'm getting 2.94. Now, remember how to get back there. We've got to do plus 2 pi k. And here we'll say plus 2 pi k. But the thing we're ignoring, or I'm ignoring, is the 3t. So 3t equals that. 3t equals that. So I'll divide everything by 3 or multiply by 1/3. So let's see. I'm going to take that number, divide it by 3. I'm getting 0.0671 plus 2 pi over 3k. And I'll get the same thing here. Let's see. What's that number? The 2.94 number divided by 3. Well, I'm getting t equals 0.980. That's good enough. Plus 2 pi over 3k. So what are my answers? How would I list this in my open math to get this right? Well, I'm going to, my first time around, here's the answer, 0.0671. Then the next one would be 0.980. Then I'm going to take 2 pi over 3 and add it to that 0.067, whatever number that is. Let's see, so plus 2 pi, since we're working with all these crazy decimals, I'm going to give a decimal answer, decimal approximation. So that gives me 2.162. And then to get the next answer, we'll add 2 pi over 3 to this number. Plus 2 pi divided by 3. I'm getting 3.074. So those are the first four solutions. How can I check to see if I'm right? So I went out to Desmos and I graphed that equation in the line, and now take a look at my answers here. Oh, this worked out well. It's always good. I'm always satisfied when it works out right. So that point, that point, this point, this point, this point, this point, this point, this point. So certainly, multiple choice question, my open math, I won't be able to know if we just graphed it, found it, but you do want to be able to do this algebraically. Okay. If you want, try this one. Get some practice here, and then come back and watch my video. Stop my video and try it, and then come back and watch it. That way you're not just listening to me. So let's see. I'm going to isolate this. They don't tell me any range. It's one thing I noticed. So I don't know if I'm solving all solutions or on 0 to 2 pi or whatever. So I think I'll just do all solutions. That way I've got it all covered. So I'm going to isolate. I'm going to isolate this. I'm going to subtract 1, divide by 3. So sine of pi over 4t equals, let's see, what is that, 1/3? I got to go to black ink, not yellow. So then I'm going to do the arc sine. I really am doing that little u substitution with the pi over 4t, but I'm just going to leave it here. I'm not going to rewrite that. So arc sine of 1/3. Let's see here. Second arc sine 1 divided by 3. I'm getting pi over 4. T equals 0.3398 plus 2 pi k. Now, ask myself, where is sine equal to positive 1/3? Well, I know it's here in quadrant 1, and I know it's here in quadrant 2. So I'm going to take, remember, this is the reference angle I just found, right? That's the 0.3398. So I'll take pi to get this angle over here. To get this angle here, I've got to do pi minus 0.3398-ish. So second pi minus that answer, I'm getting pi over 4t equals 2.8018 plus 2 pi k. And then to solve it, I got to multiply both sides by 4 over pi, right? So on this piece here, I'm gonna take 0.3398 times that by 4 divided by pi, and just write down that decimal, because that's not nice. It's just, let's see, times 4 divided by pi. So I'm getting 0.4327 plus, and then we're going to ask ourselves, what's 2 pi times 4 over pi? Well, the pi's cancel out. 2 times 4 is 8. So plus 8k. And then we'll do that same thing here. I'm going to take the 2.8018 times that by 4 divided by pi. Let's see. So that times that by 4 divided by pi. I'm getting 3.57567 plus 8k again. So here's that. Now, if they wanted me to find 4 answers or 3 answers, I would take this answer. So the first answer would be this one. Here, let me get a highlighter going here. First answer would be this one. Second answer would be this. The third answer would be the 0.432 plus 8. So 8.4327. And the next answer would be 3.567 plus 8. So it would be at what? Is 11.567, and we could keep going. I mean, that's why writing out this all solution thing is I think it's a time saver. It's a little more work up front, but it tells you so much more. Okay, so this one didn't translate correctly here. So let me rewrite this, because this will match what you have on your note sheet. This is 2 times cosine squared t plus cosine t equals 0. So what people like to do is, they don't, cosine squared, what's that? Well, one thing to keep in mind is that cosine squared t is the same as cosine times cosine. Okay, so that's the other way to write that. And maybe if you see that, you'll see that I can factor out a cosine, but maybe that's still confusing. So what if we do this little substitution? We say x equals cosine t. So it's 2 times x squared plus x equals 0. So that's it's a quadratic equation. I see a greatest common factor of x. I can factor that x out. And then what's the two answers? Well, x can equal 0 or x can equal negative 1/2, right? You just subtract 1 divided by 2. But it's not x, it's cosine. So cosine of t equals 0. And where does the cosine of t equal negative 1/2? Well, we haven't done a quadrantial angle yet, but we can. So we know cosine is x. So where is the cosine equal to 0? Well, at pi over 2. It's also equal to 0 at 3 pi over 2, or negative pi over 2 if you want. So we think this tells me I have an answer at pi over 2 and then add another pi, so I could say plus pi k. That would account for for pi over 2, and then 3 pi over 2, and then at 5 pi over 2, etc. Then where's the cosine equal to negative 1/2? Well, I know the cosine's equal to negative 1/2 at, let's see, where x equals negative 1/2 is right here. So 2 pi over 3 plus 2 pi k. That'll get us back there. And then where's the other place is equal to negative 1/2? At 4 pi over 3. So 4 pi over 3 plus 2 pi k. So there, it looks like there are 4 answers for every circle every time around. They aren't telling us what to limit our range at, my answers at, but we know we had to account for those. So again, this didn't copy well when I brought it into this recording software. So it's secant squared theta minus 5 secant theta equals 6. Well, let's see. To me, what if we say u equals secant theta? So that would give me x squared minus 5x equals 6. Quadratic equation, I'll set it equal to 0. That factors to, what does it factor to x minus 6 and x plus 1. I think that does it. So x has to equal 6. X has to equal negative 1. But remember, x is secant. Or actually, I used u over here and wrote x. Here, let me fix that. So I'm going to replace secant theta equals 6. Secant theta equals negative 1. And then secant, I don't know what secant is. So I'm going to find the reciprocal, which is the cosine. So since cosine is a reciprocal, I'm going to take the reciprocal of 1/6. Or it's a reciprocal of 6, make it 1/6. I'll take the reciprocal of negative 1. And that's also negative 1. So let's see. Where's the cosine equal to negative 1? Well, that's at pi. And to get back there, we have to say 2 pi k. To get all the way back, go all the way around again. Now, this one's a little more problematic. Here, let me slide some things up here so I can... so where does the cosine equal 1/6? Well, it's positive. So that tells me it's going to be up here in quadrant 1. So that arc cosine will tell me that answer. And then it's positive down here in quadrant 4. So that'll be 2 pi minus whatever that answer is, right? So let's see. Let's actually do this. So second cosine, arc cosine of 1 divided by 6. I'm getting 1.403 plus 2 pi k. And this one will be 2 pi minus 1.403, because that's that reference angle there, right? So 2 pi minus that answer. It's let's see, 4.87, well, let's see, 98. How many decimal places am I using? 3. I'm going to call this 0.80. 0.880 is how that rounds to. I'm getting 4.8798 on my calculator. If I want to go to 3 decimal places, that's what we're going to get. Plus 2 pi k, right? To get all the way back there. And let's see. Sometimes we have to worry about extraneous roots. In this case, I don't think we need to. I think it's going to... Have I gotten everything? Let's see. I guess we could go graph it out in Desmos and see, but... See, there's an answer, and then here's my other set of answers right here. Here. That's my other answers. So this one, again, looks like it didn't copy right. So 2 sine squared t minus 1 equals 0. So I see extracting square roots, right? If I had told you this was 2x squared minus 1 equals 0, you would add 1, divide by 2, then take the square root, right? And that's what we're going to do here. We're going to say sine squared t equals 1/2. We'll take the square root of that. Equals plus or minus, because you're taking the square root of 1 over 2. And then won't that become plus or minus 1 over root 2? And isn't that really plus or minus root 2 over 2 if we rationalize? Because that's the more standard form. This is a unit circle question. Where is the sign positive and where is the sign negative? So I know that there's going to be 4 answers. One here. One here. That takes care of the positives. And this will take care of the negatives. So I think you're going to see that if you looked at the unit circle, this would be pi over 4. Then the next one would be 3 pi over 4. That would take care of the negative, one of the negatives. And then, what is that, 5 pi over 4? Would take care of, actually, what did I say? This will take care of these are the 2 positive answers up here in the red, right? And then we'll take care of the 2 negatives. That'll be a negative root 2 over 2. And then 7 pi over 4. We'll take care of the other negative root 2. And I mean, we could do that whole plus 2 pi k thing. Or we could even shorten it up maybe, because isn't this pi apart? I mean, it's kind of mixing up our positive and negatives answers. We could say pi over 4 plus pi k. That'll take care of this positive answer and this negative answer. And then we could say 3 pi over 4 plus pi k. That'll take care of these 2 answers here. So I guess that would be the way to do it. That's the simplest way. But the important part is the extracting the square roots. And when you take the square root, to make sure you talk about the plus or minus. Oh, another one. Let's see. So I've got 2 cosine squared t plus 5 cosine t minus 3 equals 0. Well, you could do that whole substitution thing. So 2u squared plus 5u minus 3 equals 0. Let's see, does this factor? Maybe. Let's see, 2u. It'd be nice if it did factor. And u, what if we put plus 3 here? That'll give me 6. Minus 1 here will give me the negative 3, and I'll subtract it to get 5. Oh, that's a beautiful thing. So 2 cosine t minus 1 equals 0. And 2 cosine... I'm sorry. Messed that one up. Cosine t plus 3 equals 0. Well, let's take care of this one. I'm going to subtract 3 from both sides. The trouble with this is the minimum for cosine is -1, because that amplitude is 1. So this is going to be an extraneous root. We don't need to do anything more with that. That's dead. For this one, we're going to say cosine t equals 1/2. Well, we know where's cosine positive. We know it's positive in quadrant 1s and quadrant 4. And we know, I think it's pi over 6. So we know it's pi over 6 plus 2 pi k to get all the way back there. And then the other one will be what? 11 pi over 6 plus 2 pi k. Let me pull up a unit circle chart. Make sure I didn't mess that one up. As I suspected, I did mess it up, because cosine, I was thinking sine, or actually I don't know what I was thinking. But if I look at my unit circle, I'm looking for where is this equal to 1/2, right? Positive 1/2. And it's the x value. So it's going to be pi over 3 and 5 pi over 3. That's a good thing I looked. You probably noticed that when I did that. So here, this should be an easy fix. So pi over 3 and what was the other one? 5 pi over 3. The adjacent side would have to be the 1. Yeah. Okay. So hopefully that didn't confuse you and you see how we did that. So remember what was new and different about this one was that extraneous root over here. So you gotta, those will pop up and we're checking to see if you know how to do that. Another quadratic. Except what's different with this one? 2 cosine squared t plus sine t minus 1 equals 0. Here they're mixing up the sines and the cosines on me. And so far I've only been working with all straight sines or all straight cosines. So now we've got to try to do something, use one of those identities to make it either be all one or the other. To me, I know that 1 minus sine squared t is the same as cosine squared t. So I'm thinking that's what I'm going to substitute in. And that way I'm just dealing with sine. So that'll give me 2 minus 2 sine squared t plus sine t minus 1 equals 0. So I'm going to move this so the sine squared t is positive, which means I'm going to move everything over to the left. Over to the right. So 2 sine squared t minus sine t, and then let's see, 2 minus 1 is 1, so it was plus 1, so now it becomes minus 1. And let's see if this factors. So remember, I could do that substitution. I think maybe you're starting to see you don't have to, you're just going to back substitute it. So let's see, I need to get positive 1, negative 1. I want a negative in the middle. I think if I go negative 1 here and positive 1 here, let's see, what do I get? I'm going to get negative 2 plus 1 is negative 1, or negative 1 sine, yep. And negative 1, yes, that works. That factored well. Oh, nice. So then we're going to say, use that zero product property, where does 2 sine t plus 1 equals 0, or where does sine t equal negative 1/2? And where does sine t equal positive 1? Well, this is easy. This is at pi over 2. And if we want to get back there, we got to do plus 2 pi k. So that's one set of answers. Then we're going to say, where is the sign negative? So if we think about our unit circle, and this time I'm not going to get it wrong, they're both down in quadrant 3 and 4. I know that reference angle's 30, or pi over 6. That's pi over 6. So the first answer is going to be what? 7 pi over 6 plus 2 pi times k. And then it's going to be 11 pi over 6 plus 2 pi k. So those are going to be those 3 sets of answers. And we can graph it and check it. Okay, so now this one, let's see, I see sine x equals cosine squared x. This is very similar to that other one I did. Why don't you stop the video and try it, and then come back and check it out, okay? So I want this in terms to be sine or cosine. I don't care which. I see the cosine squared. I know 1 minus sine squared is the same thing. So sine x equals 1 minus sine squared x. I see a quadratic equation. I want to set it equal to 0. I want the leading thing to be positive to make it easy to factor. So I'm going to move the sine squared x to the left. I'm going to move the 1 to the left. And I don't think that factors, so I'm going to throw it in a quadratic formula. And my handy-dandy calculator that has that program that solves quadratic equations. A is 1, B is 1, C is negative 1. I'm getting x equals 0.618. I'm getting x equals negative 1.618. Actually, this is sine x, isn't it? So I'm hoping over here to the right you see a problem. Sine can't be negative more than negative 1 or less than negative 1. So that's an extraneous root. We're not even going to look at it. This one, however, I'm going to ask myself, sine is positive up here in quadrant 1 and quadrant 3. So we'll do the arc sine of 0.618. So arc sine of 0.618. My calculator's telling me that this is equal to 0.6662. So that's that reference angle. So that'll be one answer plus 2 pi k. To get the other answer, we're going to do pi minus 0.6662, because remember, that's that reference angle there, and we want this angle. So pi minus that answer, I'm getting 2.475 plus 2 pi k to get back there. Okay, so I see a cotangent, I see a cosine. Well, I know I probably want to... What do I want to do? I'll tackle it this way. I do know I want to get rid of the cotangent, so I'm going to think of that as cosine A over sine A equals 4 cosine A. Isn't this just a proportion? I could do the cross products. So cosine A equals 4 cosine A times the sine of A. And then I'm going to set these in on both sides. I'm going to move everything over to one side. I think what I'm going to do is subtract the cosine A from the left. So 0 equals 4 cosine A times the sine of A minus the cosine of A. Some of you might be tempted to divide both sides by cosine, but you'll be losing, potentially you could be losing an answer. I think this time, in this case situation, you would. So what we'll do is we'll do it this way. It will factor out a cosine times 4 sine A minus 1 equals 0. So where does the cosine equal 0? Where does the sine of A equal positive 1/4? Well, we know cosine is 0 at pi over 2. And then you go halfway around, you're at 3 pi over 2, so plus pi k. So that's one set of answers. Now this one, sine's positive here in quadrant 1. Sine is positive here over in quadrant 2. So if we do the arc sine of 1/4, that's going to give me what? Arc sine of... I'm just thinking if I've got an extraneous root with a cotangent of root of pi over 2. But let's get back there. Let's see. Let's finish this part and we'll go check. Let's see. So arc sine of 0.25. I'm getting 0.2527, and this is also 0.2527. So one of my answers is 0.2527 plus 2 pi k to get all the way around. And then the other one's going to be pi minus 0.2527. That'll give me this angle here. So second pi minus that answer. Let's see. So I'm getting 2.889 plus 2 pi k. I'm not too concerned with those answers being extraneous. I am wondering about this one. So I got to go back up and take a look at the cotangent thing. Originally it was cotangent, so then I'm asking myself, is cotangent defined at pi over 2? I know tangent's not, but remember how cotangent shifted to the right pi over 2? Yeah, so cotangent graphs look like this, don't they? So yeah, that's going to be 0. Yep. So that checks. So we have these sets of answers. So that one is one set, or actually it's a double set because you get pi over 2, 3 pi over 2, etc. And then these two decimal answers. So this one is supposed to have been written 1 plus sine and negative x equals cosine squared of x. So a couple of things are happening here that's kind of a pain. That sine negative x. Well, if you think back to those negative identities, or sine is an odd function, which means if sine's an odd function, f of negative x equals negative f of x. Remember that from way back when, week 1, I think it was? So we can do some rewriting here. We can rewrite this as 1 minus sine x, so that's taken care of. And we've already done this substitution a couple of times where this is sine squared x. So I see a quadratic equation. I'm going to set it equal to 0. So I'm going to move sine squared x to the left, minus sine x, and then 1 minus 1 is 0, so we've just got to factor out a sine x. So where does sine x equals 0? Well, at 0 and at pi. So why don't we just say 0 plus pi k? That'll take care of all those answers. And where does sine x equal 1? Well, that's at pi over 2, and we got to go all the way around to get back there. So there's that set of answers. So here I'm seeing a new identity. This is from section 7.3 or 7.2. This is the angles. This is a an angle sum identity. And if you look at that identity chart, you're gonna see this set of identities, the sum difference formula. So what's one way to tell which is which? I see cosine cosine. So see how this formula says cosine cosine, and then you notice how the negative comes in on top. So if you're adding two angles, you're going to have a negative, and that's what's happening here. Notice how it's cosine cosine sine sine, cosine cosine sine sine. There's a negative in between them. That means I'm going to add those two. I'm going to add x and 2x. Now, what did that do for us? Well, for one thing, it simplifies this down pretty well. So this is the same as cosine of 3x, because 1x was 2x, and that's root 2 over 2. So then we can say, okay, what angle? So we're going to say u equals 3x momentarily again. So the cosine of u equals root 2 over 2. That's a unit circle problem, right? Cosine's positive, so we'll know that 3x will equal, what is that? Pi over 4 plus 2 pi k. And we'll know that 3x equals 7 pi over 4 down in quadrant 4. You can go check that out in the unit circle. I'm pretty sure I'm right here. So I'm going to divide by 3, divide by 3, divide by 3, or multiply by 1/3. So x equals pi over 12 plus 2 pi over 3k. And the other one will be 7 pi over 12 plus 2 pi over 3k. So there's the two sets of answers. So now we're sliding into section 7.3 where they have these double angle identities. And these come up, I haven't ever seen, I don't teach Calc 1, Calc 2 for CCV, but I do teach AP Calc for which is Calc 1. For Oxbow, this double angle identity comes up. I've never seen the angle sum identity come up, other than when you're learning about derivatives and all that. That does come up, but you can get by without that. So what we're going to do is you're going to look at that trig identity sheet, and you're going to see, because I see it, the sine 2x, which is different than sine x. So what you're going to see is you're going to see this identity, the identity that says sine 2u equals 2 sine u cosine u. And that's equal to sine x. And then you can say, oh, well, I see a common factor, so what I'm going to do is just subtract sine x from both sides here. Just a minute here. Cosine x minus sine x equals 0. I brought this over. Now I'm going to factor out of sine x. That's a wonky sign, Dan. So I'm going to factor out of sine x. That's going to leave 2 cosine x minus 1 equals 0. So where does the sine of x equal 0? It equals 0 at 0 and at pi. Whoops, not 2 pi, Dan, 1 pi. So that takes care of those set of answers. And where does the cosine of x equal 1/2? Well, let's see. I know it was pi, so it's positive here and here. I think I already solved this and I messed it up, as I recall. So pi over 3 plus 2 pi k to get back there. And what is that? 5 pi over 3 plus 2 pi k to get back there. So those are the set of answers for that answer. Now that really isn't that bad a problem, is it? And the last one in this very long video. So this says cosine 2x equals sine squared x. That didn't translate well when I brought it in. Let's see. If I look at those double angle identities, sine isn't sine. The sine double angle form is always so nice. There's only one. With cosine, you get 3 choices, and depending which one you want to use depends on the situation. As I'm looking at this, I've just got a sine squared on the side. I think I want to come up with something that just has a sine squared. I don't want to use it any more cosine. So I think the right one to use is this one here. So, and you'll know very quickly if you chose the wrong one, because it'll get very complicated in a hurry. And that's not to say they aren't always complicated, but... So let's see, how do we solve this one? Well, I see it's kind of like a quadratic. I'm going to add, well, it is a quadratic. I'm going to add 2 sine squared x to both sides. So that'll give me 3 sine squared x. I'll divide by 3. And then I'm going to take the square root. So that's going to give me the square root plus or minus the square root of 1 over 3. That's equal to sine x. So doesn't that clean up to plus or minus the root 3 over 3? And that's what's equal to sine x. And then I think, isn't this, maybe I'm thinking tan. Yeah, let's move that up. I'm really thinking, I know there's 4 answers, and I know there's going to be 1 in each quadrant. So what's the arc sine here? What we're going to do is we're going to do the arc sine. I'm not going to try to get too fancy. I think I'm going to jump right to a calculator here. So what's the arc sine of the square root of 3 over 3? I guess I could just do the square root of 1/3, since it's not going to be a nice number. I think isn't tangent root 3 over 3, 1 over root 3, yeah, this is sine. So that won't work. So let's see, arc sine of square root of 3 divided by 3. My calculator is telling me that that's equal to 0.6154. And that's what x is equal to. Now, I know it can be plus or minus. So there's going to be 1 in each quadrant. So there's the 0.6154. This one also has 0.6154, which is that angle. So the second answer is going to be pi minus 0.6154. The third answer is going to be down here. This is the negatives. It's going to be that one. So won't that be pi plus 0.6154? And then the other negative here, what can I use for? I guess you can use black. That's also 0.6154. So that'll be 2 pi minus 0.6154. And I'm not going to bother crunching all those numbers. But that's what I think these answers are for this. And that's the end of 20 or 19 long questions. You know, comes with practice. So whether you want to go do some out of the book, it's up to you. Certainly math has plenty, and they all have videos attached. So, and give a yell if you need any help.